Okay, this is hopefully the completion of notes for 4-6. I'm announcing that the quiz 4-5-4-6 is on Monday. You already know homework 6 is due on Monday. And I just want to revisit this last thing that we said before we left, or yeah, I think it was the last thing. So we talked about this. If we have the inverse sine of the sine of pi over 6, we know the sine of pi over 6, and I just re-put this here. So the sine of pi over 6 is 1/2, and so that's the inverse sine of 1/2. And I'm going to add in this all students take calculus, oops, because that will be important. All students take calculus. And for sine, the nice thing when we're doing inverse sine is it's either the reference angle positive, and then that's it, or the reference angle negative, and then it's just the negative angle. And so the inverse sine of 1/2, well, that reference angle is 1 pi over 6, and so it is the same answer. So this is what we want to figure out. Is it always the same answer? And so then we did this, and I think I kind of felt like we had almost finished this. So all students take calculus for the cosine of 5 pi over 6. So I'll change maybe to black, this black color. So 5 pi over 6, remember, is like over here. And so the reference angle is pi over 6. For that one, the reference angle is pi over 6. And all students take calculus. So sine is positive, but cosine is negative. So the cosine of 5 pi over 6, and again, we're at this pi over 6, and it's the square root of 3 over 2, but it's going to be negative. So then when we go the inverse cosine of 3 pi, or negative square root of 3 over 2. Let me put that. Then when we're doing the inverse, well, if it's negative for cosine, the reference angle is either here or there. If it's positive, the reference angle is the angle. If it's negative, though, the reference angle is here, and it's this whole angle. So the reference angle for the square root of 3 over 2 is still that pi over 6, but now the reference angle is pi over 6, so this angle is 5 pi over 6. So these two examples make me think that if I do the inverse sine of the sine of an angle, I get the angle. And if I do the inverse cosine of the cosine of an angle, I get the angle. But now I want to look at what happens if maybe that's in a different location as I go through. And so I'll just pick something like the inverse sine of the sine of 5 pi over 6. Just give me a head nod. Do you think the answer is 5 pi over 6? Okay. All right. So let's think this through a minute. So in the inside here, I just want to get the sine of 5 pi over 6. So here I am. My reference angle is pi over 6. All students take calculus. And so pi over 6 is still my reference angle. Sine of pi over 6 is 1/2. But I'm in this quadrant. So sine is still positive 1/2. Do you agree? Okay, so this is positive 1/2. So then I have to find the inverse sine of positive 1/2. Well, the inverse sine, remember, all students take calculus. For sine, it's that one that if you find the reference angle and it's positive, it is that. If you find the reference angle and it's negative, it's just the negative of that. So what's the inverse sine of 1/2? It's the positive one. It's pi over 6. So this one is not the case. And I want you to think about why that is. Because think about this angle right here. It's not in these two quadrants, right? And even if it were in this quadrant, if we had gone all the way, from here around to there, we wouldn't get, let's say that reference angle is still pi over 6. We wouldn't get that all the way around when we do this inverse sine. We would just get that short distance there. So sometimes this works, sometimes it doesn't. When in doubt, Just figure it out. And that's what we're doing right here, is we're just saying, okay, I'm not using a rule, I'm not figuring anything out, but I'm just going to kind of look at it. So we do have a series of rules. Here's what they say. And I'm going to start with this set first because that's how I talked about these. So and this is not to say that if it's not this, that there's no answer. Because, you know, think of that one we just did. There was an answer, it just wasn't that this and this were identical. So if we're taking the inverse sine of the sine of an angle, and that angle is between negative pi over 2 and pi over 2, all students take calculus, then we'll be in those two quadrants, and the inverse sine of the sine of x is just equal to plain old x. Likewise, if we're doing the inverse cosine of the cosine of x, think about those inverses. All students take calculus. There, for the inverse cosine, we use from 0 to pi. So if that angle right here is between 0 and pi, then if we do the inverse cosine of the cosine of that angle, we just get that same number, okay? As long as it's in the interval for the inverse. Same thing with tangent. We didn't look at any of those, but we know when we do inverse tangent, all students take calculus, that inverse tangent is just like sine, so it goes from negative pi over 2 to pi over 2, but it doesn't include those. That when we look at that, then if we're between negative pi over 2 and pi over 2, if we take the inverse tangent of the tangent of x, we get x. So it's a super handy idea, but keep in mind that it's only going to work sometimes. So look, anytime you're spinning around like more than once, right? Spinning around more than once or either direction, then it's going to be related to that reference angle for that angle, but it's not going to be the exact angle. So for inverse sine of the sine of x, it's got to be in between negative pi over 2 and pi over 2. Then this is kind of doing it the other way. So here, x was an angle. Do you agree with that? Because it's the sine of the angle. So that was the angle. Now, in these, the inverse is kind of inside, nested inside there. And so for these, that's the ratio. So the ratio of the angle for sine, and then we take the sine of that, we're going to get the same value if it's between negative 1 and 1. Does that make sense? Because that's the negative 1 and 1 that sine is between. So this is talking more about where those ratios are as we go through. So like sometimes these, well, sometimes any of these could be undefined, I guess. But especially here, if I'm trying to find the inverse sine of 5, well, when is the sine ever going to be 5? You know, it's not. And so that's not going to work as we go through that. So this is the compositions of domains of the compositions of functions. And you'll notice this. These words are the same, correct? So what are we going to do when those words are not the same words and one is an inverse and one is not? And as we go down the road, we'll kind of talk about that as well. So here's our first problem, and I just put on my little tables because I guess I felt a little bit worried about our time dynamic. So if we need to look at the table, you just tell me, I'll slide it out here. And so this is 6a. It's the sine of the arc sine of 1/2. So, you know, we had talked about angles a minute ago. Now we're talking about ratios. And so let's kind of work it through and kind of see what we get. So the arc sine of 1/2, that means if the ratio of sine is 1/2, what's the angle? What is it? Gosh, like all answers are what today? It's pi over 6. Yeah, all answers, all roads lead to pi over 6 evidently right now. So that's pi over 6. So then I know the arc sine of 1/2 is pi over 6. So then I'm just finding the sine of pi over 6. Well, what's the sine of pi over 6? 1/2. So it falls into this category of the sine of the arc sine of 1/2 is 1/2. So when in doubt, just work it out, because it will work out whether it's going to be the identical thing or not. And, you know, like in desperation, what would you write? You know, whatever's there, you're going to write there, because that, you know, that's what you have a shot at, I guess, as we go through. So let's do this one. Inverse cosine, 6b, of the cosine of 5 pi over 2. Just give me a head nod. Do you think it's 5 pi over 2? All right, well, we'll find out. And let's kind of think about this in our heads as well. My first inclination is that it's probably not, because 5 pi over 2 isn't on this table, and it's not between 0 and pi, right? It's 5 pi over 2. That's like over 2 pi, right? So my thought is it's probably not going to be one of these, but let's see what happens. So this is first the cosine of 5 pi over 2, and I have to count that out. So remember, this is 0, pi over 2, little review, pi, 3 pi over 2, you know, 2 pi or 4 pi over 2. I'll just count it that way. And then 5 pi over 2, I would end up right here. So what I did is I spun all the way around, and then I'm stopping right there. And so if I put a point there, that's kind of how I like to do this. That point would be 0, 1. So, you know, or I could say to myself, my reference angle is pi over 2. And that would work too. My reference angle is pi over 2, so I'm going to get that 0 over there. So the cosine, and this is always cosine, sine, the cosine of 5 pi over 2 is 0. And so then I'm going to find the inverse cosine of 0. Well, for the inverse cosine, all students take calculus, I'm allowed to use anything from 0 to pi. And so I can just look right on here. There's my 0 again. My reference angle is pi over 2. And so is my reference angle the answer to this question, cosine, inverse cosine of 0? Yeah, it's pi over 2. So just a note to self, they don't give us a lot of these, but a note to self is that reference angle is going to be important, right? Because it's either going to be exactly equal to that angle that we're talking about, or it's going to have the same reference angle. So just something to kind of keep in mind as you're going through these problems. And so now we want to do this problem with the arctangent of the tangent of negative 5 pi over 2. So it's that same angle. So 6c, the arctangent of the tangent of, oh no, it is not the same angle. It's negative 5 pi over 2. My bad for that. So negative 5 pi over 2, but I know what's going to happen. So I'm going to work my way through this. Now, give me an answer for this one. The arctangent of the tangent of negative 5 pi over 2, do you think it's going to be negative 5 pi over 2? I don't think it is either, because when I do the arctangent, I can go from negative pi over 2 to pi over 2, right? So that's not in the range. But that doesn't mean to say I can't get an answer. So let's look at this, negative 5 pi over 2. So I'm going this way. 2 pi over 2, sorry, 3, 4, 5. So now I ended up here, which is 0, negative 1 for my point. And remember, that's cosine over sine. And I have my table of values. My reference angle is 9 pi over 2, or 90 degrees, I was going to say. I don't know why. What is the tangent of pi over 2? Undefined. It's undefined, and that's my reference angle is pi over 2. And so the tangent of negative 5 pi over 2 is undefined, But that's okay. That doesn't mean that this is not a defined thing, because now I want to find the arctangent arctangent of something that's undefined, my ratio that's undefined. Well, if my ratio is undefined when I find the tangent, what's the reference angle? If tangent of something is undefined, what's that something? Pi over 2, right? So I know the tangent of something is undefined. Well, my reference angle is pi over 2. So this tells me my reference angle is pi over 2. And really, I want to keep that picture in mind because, how do I know whether it's, positive or negative? I know it's positive or negative because I can look at that picture. And I ended right here. So all students take calculus for inverse tangent or arctangent. I can only be in one of these two. I know my dot is right there. So is it positive pi over 2 or negative pi over 2? Negative pi over 2. And so equals negative pi over 2. Notice I'm in that same location, but I am not getting the exact same answer as I look at those. So just be careful, as we go through that a little bit. Now, what's different about this one? Right, they're not the same trig functions. So I can't even do this, inverse of the whatever. And I'm asked to find an exact value. Is 4/5 on our table? Anywhere? No. So it's not on our table, but there's a way for us to do this. And one thing that we will kind of use as our expectation is we're going to use the expectation that we're going to be using positive values when we do a problem like this. Similarly, when we have a variable here, because we will. So this is number 7, the sine of the inverse cosine of 4/5. So the first thing we're going to do is deal with this inverse cosine of 4/5 equals, so do you agree that the inverse cosine is like theta then, right? Because this is the ratio, so the inverse cosine is theta. That means that the cosine of theta is 4/5. And this is a super handy fraction for us because it's going to be a 3, 4, 5 triangle. But if it wasn't, we can kind of deal with that. So that means that if I have an angle theta here, what side could I assign 4 and what side could I assign 5? The what and the what? Yep, adjacent and hypotenuse. And so the adjacent's 4, hypotenuse is 5. If it weren't a 3, 4, 5 triangle, we know that we could go the square root of 5 squared minus 4 squared, square root of 25 minus 16, square root of 9, and so that is 3. Now, do I know theta right this minute? Well, do I know it right this minute? I could figure it out if I wanted to, but right now I don't know it. And not only that, I don't need to know it because what do I have to find of theta? I have to find the sine, right? So do I even care what theta is? No, I'm going to bypass that, and now I'm going to find the sine of all of this, which is kind of my theta, remember? I'm going to find the sine of theta, that kind of mess, and then sine is opposite over hypotenuse, which is 3 over 5 as we go. Yeah. Yeah, so it's an exact value. Keep in mind this one is 3, 4, and 5, so it could have been a radical. We put it in simple radical form. We rationalize the denominator if we need to as we go through these, and we should be able to do that. So I have another problem just like this, except I have another problem just like this, except there are no numbers. It's all variables, okay? So we know how to do the Pythagorean theorem. So if I know one of those sides, I can use the Pythagorean theorem to find the other one. So here is our next problem. So now we have to use an algebraic expression and get an answer that doesn't involve trig functions. So this is number 8, and we're finding the cotangent of the arc cosine of x. So this is just like the last problem, kind of, you know. It was, what was the last one? The last one was the sine of the inverse cosine. So it was a trig function of an inverse trig function. And this is doing that same thing. So we're going to do the exact same thing right now. So we're going to look at the arc cosine of x. So the arc cosine of x equals, because that's the trig ratio that is going to give us the angle. So that means that the cosine of theta is equal to x. But I'm going to write x as x over 1. Does that make sense to you? Because I want to think of that as a ratio. X is x over 1. Because cosine theta is what kind of side over what kind of side? Cosine? Opposite, say it again, or adjacent over hypotenuse, right? Oh, cosine, if the cosine of an angle is x over 1, it's adjacent over hypotenuse. Do you agree? And maybe I didn't say it right the first time. Adjacent over hypotenuse. So now I can get my right triangle, and maybe I'll just kind of slide that up a little bit. So here's my right triangle. Theta, I don't know. I'm never going to know, and I probably can't even know it. It's not like that other one where I could figure it out. And so this is the adjacent side. That's the hypotenuse. And I didn't put my little right angle in there. And now, can I figure out what the opposite side is? Well, do I need it? Yeah, I do. I'm just checking. Can I figure out what the opposite side is? What is it? The what of that? Yep. And so it's the square root of 1 squared minus x squared, because that's the hypotenuse. Square root of 1 squared is 1 minus x squared. And just note to self, don't forget your good background in mathematics. You know, that's not going to be 1 minus x. It's 1 minus x squared, because it's added or subtracted. You can't, like, you know, take the square roots of things. So that's my situation. I don't know the angle theta. I will never know the angle theta. But I don't care what the angle theta is, because I just have to find the cosine, or excuse me, cotangent of this situation, which is going to be that theta. The arc cosine is an angle. So I need to know really the cotangent of theta. And so tangent is opposite over adjacent, so cotangent is what? Adjacent over opposite. And so then here's our thing, adjacent over opposite, x over the square root of 1 minus x squared. Now, I am going to say we're in a particular math class where we know that that's not a rationalized denominator. And we're going to rationalize it. We're not going to tamper with it too much. But I don't want a radical in the denominator, correct? And so to get rid of that, I'm going to multiply by the square root of 1 minus x squared over or under square root of 1 minus x squared. This is the fraction of 1, correct? And when I multiply those two, I'm going to get x, the square root of 1 minus x squared. I am leaving that numerator as is. That's just going to be it. And then if I take the square root of 1 minus x squared times the square root of 1 minus x squared, I get the square root of 1 minus x squared squared. And so that will be 1 minus x squared. And that's how I can kind of remove that parentheses. So if I need to find the cotangent of the arc cosine of x, it's equal to x, the square root of 1 minus x squared over 1 minus x squared. And likewise on that previous problem, when we went through that one, Um, if we had gotten something that was a radical, we would be able to put it in simple radical form as we go through that. So here's what I have for you to do next. And I will tell you that when I was trying these today, they're a little small to look at. And so some of the axes are a little bit difficult to follow, but we'll just do the best that we can. So I'm going to give you these handouts, and I'm going to have you do 4-6 first, and then 4-5. So I'm going to give you 4-6 right away, and I feel like they're more visible on 4-6 anyway. So here is 4-6. You can use your notes, and then I'll wait like 5 minutes or so, and then I'll give you the 4-5 one. And I'm going to be super honest and say the 4-5 one, sometimes I couldn't answer them just because I can't see the axes as we go. Did you need another one? Sorry. And so I'm going to stop the recording or pause it. This is always hard for me. That's pause, right? So I didn't go through the answers for the first couple, but here they are. 1, A, 2, C, 3, D, 4, B. I'm on 4. This is my work so far. I did negative pi over 2, negative pi over 4, 0, pi over 4, and pi over 2. And then when I put those in, the sign of pi over 2, or excuse me, negative pi over 2 is negative 1, so that's negative a half. I'll just do a few of these. Sine of 0 is 0. 0 times a half is 0. Pi over 2, it's 1/2. And so B is the correct one there. This one is just like that one we had done. Does anybody know what it is? D. D for that one. And I'm just going to move along. What is the arc sine of the sine of 7 pi over 6? A. It's not 7 pi over 6, but it's the same reference angle. What is the cosine of the arc sine of 8/17? D, right? And so for that one, you're doing this, the sine, so it's 8 and 17. What is that, 15, right? Okay, and then the cosine of that, 15 over 17. Number 8. C is the key. That is right. So theta is here, the arctangent of x. That means the tangent of this angle is x over 1. So this is x, the square root of x squared plus 1. And then we're finding the cosine, which is adjacent over hypotenuse, 1 over the square root of x squared plus 1. Rationalizing the denominator, we get the square root of x squared plus 1 over x squared plus 1. Was that it for those? Yep. Then these other ones are kind of hard to see. Oops, that's the same one. But these are from 4-5, and I will just kind of go over them at least sort of quickly. So asymptotes for the tangent 4x, just a reminder, a plane tangent function has asymptotes at negative pi over 2 and pi over 2. So that means you set this 4x equal to negative pi over 2 and 4x equal to pi over 2. When I multiply by 1/4, right, instead of divide by 4, I get x equals negative pi over 8 and x equals pi over 8. Well, what is happening here? I'm at negative 1 pi over 8, 1 pi over 8. What's the next asymptote going to be? It's in the eighths, I'll tell you that. So, well, it's going to be n pi over 8, or, yeah, they did it, n pi over 8. But this is 1, this is, or negative 1, 1. What's the next one going to be? 3. 3. It's going to be, and so which one of these is it? Well, D. It's D, and that's the only one. But notice it says N is an odd integer there. The next one, which maybe I didn't get to. I don't know what happened there. So, for the next one is B. So here's the next one, and I do want to go over these. Oh, look, I can't even, something's happening there. Oh, yeah. Whew. Okay, so maybe I'm just going to sit here for a minute. So this is the tangent of 4x, and so it's kind of the same thing. Our asymptotes are at negative pi over 8 and pi over 8, and so the trick is to find ones with the asymptotes at negative pi over 8 and pi over 8. If this is pi over 4 right there. This is pi over 8. So that one is letter B for that one. Vertical asymptotes. Tangent, the asymptotes are at negative pi over 2 and pi over 2 again. So you take this and you set it equal to plus pi equal to negative pi over 2 for the first one. 3x plus pi equals positive pi over 2 for the right-hand asymptote. Look, help me with the arithmetic. If I subtract 2 pi over 2, what do I have there? Am I right? Yeah. Okay, so x is negative 3 pi over what? 6. When I subtract 2 pi over 2 here, what do I get? Minus pi over 2. X is negative pi over 6. So it's either A or D. Do you agree? Yes. Okay, which one is it? It is A. And here's how we know, because look, negative 3 pi over 6, negative 1 pi over 6. It skipped the negative 2, right? So you're using the odd. A is the answer for that one. Next one, I'll just give you the answers so you have them. This one is B, because you're taking a quiz next time. Number 3, B is B. Number 4A is B or C. Why is it B or C? They're the same answer. Yes. And this one is D. And what's the damping factor? A for that one. Either turn these in today or Monday. Quizzes Monday, homework's due Monday. Stack the chairs.